Hello, let's talk about oxidation numbers. So what are oxidation numbers? So oxidation numbers are the charge an atom would have in a compound if electron transfer happens. Oxidation numbers are closely related with the electronegativity of an atom. Okay, so what are some of the rules of assigning oxidation number? The first rule is atoms in elemental form. So any atoms in elemental form, whether it be solid or diatomic molecules, will have an oxidation number of 0. Then let's talk about simple ions. So simple ions, the ion charge will be the oxidation number. So for example, over here, calcium 2 plus, the oxidation number of calcium 2 plus would be 2 plus, plus 2. Na plus, the oxidation number of Na plus would be plus 1. Simple ionic compounds. Now if there's a simple ionic compound, then the sum of the ion charge should equal to 0. So NaCl, and it makes sense because Na would be plus and Cl would be minus. And as I said before, that oxidation numbers are closely related with the electronegativities. So what will happen is sodium will lose the electron and chlorine will gain it because it's highly electronegative, or at least more electronegative than sodium. So the simple ionic compound, the sum of ion charge would be 0. That would be really helpful in further examples. Let's talk about hydrogen. So hydrogen is a weird case because with metal and boron, it's -1. And with non-metal, it's +1. Now, it makes sense because with metal, hydrogen is one of those elements which is more electronegative than most of the metals. So that would be sodium or other metals. But hydrogen with non-metals is +1. And that kind of makes sense because hydrogen would love to lose electron and the highly electronegative nonmetal will gain it because it's more electronegative. So it makes sense that hydrogen will be +1 in that case. Now let's go to oxygen. When oxygen is with everything else except H2O2, which is hydrogen peroxide, the oxidation number of oxygen is -2. But within H2O2, the oxidation number of oxygen is -1. Using these two simple rules, which is simple ionic compound rule and hydrogen rule, we can even calculate the oxidation number of oxygen in H2O2. So hydrogen in this case is with oxygen, which is a nonmetal. So the oxidation number on hydrogen would be +1. But as there are two hydrogens, it should be +1 times 2, which is +2. As per the simple ionic compound rule, the ion charge of H2O2 should be 0 because it's a neutral compound. So in that case, it would be +2, -2, and then there are two oxygens, so that should be -2 divided by 2, which is -1. Now halogens. Halogens are highly electronegative, and their oxidation number would like to be negative. Fluorine is the most electronegative atom, so it has to be -1. Chlorine, bromine, iodine are also -1. Exceptions exist for chlorine, bromine, and iodine. Steps of assigning the oxidation numbers. You can look at these as the priorities more than the steps. So the first priority we always give to is hydrogen. Hydrogen is always assigned first, then it's oxygen, then other halogens, and then everything else. Now let's do some practice because practice makes everything clear. SO3, sulfur trioxide. According to our priority scale, we would assign oxidation number to oxygen first. So that would be -2, and then as there are 3 oxygens, we multiply that by 3, making it -6. Now this is a simple ionic compound with no overall charge. It's a neutral charge. So that means that if oxygen is -6, sulfur has to be +6. And there's only one sulfur, meaning sulfur is +6 and oxygen is -2. The second example we're looking at is C6H12O6, sugar. According to our priority scale, the first atom that we assign oxidation number is to hydrogen. Hydrogen is +1 because these are nonmetals. 12 hydrogens, so we multiply +1 by 12, making it +12. Oxygen is the second atom that we assign oxidation numbers to. There's 6 oxygens, and the oxidation number of oxygen is -2. There's only one exception, which is H2O2. We multiply -2 by 6, and we get -12. Now when you add these together, we get the oxidation number charge, or oxidation number sum, to be 0. That means that carbon has to be 0, because if carbon has a negative or a positive number, we won't get the sum to be 0. Carbon has to be 0, hydrogen has to be +1, and oxygen has to be -2. The third example we are looking at is Cr2O72-. Cr2O72- is not a neutral compound. It's an anion because it has a -2 charge. This means that the sum of the oxidation numbers of the atoms should equal 2-. Okay, so we're here in between these two atoms. The first atom that we assign oxidation number is to oxygen. Oxygen has to be -2 here. 7 oxygen, so we multiply by 7, -14. Now Cr2. Cr2 is a metal. And when you actually think about it, the sum has to be -2, meaning Cr2 has to be +12, because if it is +10, this is -4, and if this is +14, this is 0. So the only way the overall oxidation sum is 2-, or -2 I mean, is by having Cr2 as +12. There's 2 Crs, so we divide +12 by 2, and the oxidation number for Cr would be +6. And oxygen would be -2. Let's look at the fourth example. Fourth example is this complex compound. This is probably the most complex you will go. This is an ionic compound, and the best way to do this is to break this compound down into its ions. So Ca in the brackets HCO3 would break down into Ca2+ and HCO3-. Now calcium 2+ would have an oxidation number of +2. HCO3- is similar to Cr2O72-. The sum of the oxidation numbers of all of these atoms have to be -1. According to a priority list, hydrogen has to be assigned first. Hydrogen is +1, and there's only one hydrogen. Oxygen is -2 here. There are 3 oxygens, so we multiply by 3, so we get -6. Now when you add these together, you only get -5. So carbon has to be +4 because that is the only way we get the overall sum to be -1. And it makes sense because oxygen is the most electronegative atom here, so it has to be negative. And then hydrogen has to be +1 because it's with nonmetals.